Dear students, now we will take up the topic units and dimensional analysis. This chapter is very important for an engineering diploma student because the knowledge given in this chapter about the units and dimensions is very important in further understanding of the subjects in their engineering branches. So, this chapter is very important. In this chapter, we will discuss about the various units and various systems of units. We will discuss what are dimensions and what are their applications. So, this chapter is very important. So, first of all, we will take up the what is the unit. Before we take up this unit, we will discuss what are physical quantities. The quantities which can be measured directly or indirectly are called physical quantities. There are large number of quantities in physics, in science, in engineering, which can be measured either directly or indirectly. Such quantities are called physical quantities. So, what are physical quantities which can be measured? You know, we can measure length, we can measure mass, we can measure time, we can measure temperature. We can also calculate area by measuring length and breadth. We can measure volume by length, breadth and height. We can measure density. We can measure speed. Such quantities, the quantities on left hand side are measured directly. Length can be measured directly, mass can be measured directly, time can be measured directly, temperature can be measured directly, area, volume, density, speed, such quantities are measured indirectly. So, such these physical quantities can be divided into two categories. One is called fundamental or basic quantity, another is called derived quantity. Physical quantity are further divided into two categories, fundamental or basic, and the second class is derived quantity. In this list of quantities, length, mass, time, temperature, they are called fundamental. They are called fundamental because these quantities are not related to each other, neither they depend upon other quantities. Such quantities which do not depend upon each other or on other quantities are called fundamental quantities. On the other hand, the quantities like area, volume, density, speed, which are derived from fundamental quantities either by multiplication or by dividing the two fundamental quantities. These quantities are called derived quantities. So, area is derived from fundamental, length and breadth, volume, density, speed. So, these are the second category, they are the derived quantity. This was the fundamental quantity and these are the derived quantities. So, we must have knowledge about that which type of quantity should be that in which class we should take up, that length, mass, time are fundamental, and other quantities like area, volume, density, speed are called derived quantities. Now, to measure a quantity, we need a unit. What is unit? The standard chosen of the same kind as the quantity is called unit. Whenever we are to measure a quantity, we need a unit. We compare the quantity with a standard of the same type, like if we are to measure length, that will be measured that will be compared with a standard length, or if we are to measure mass, that will be compared with a standard mass. So, that standard which is chosen of the same kind as the quantity, that is called unit, like meter for length, like kilogram for mass. So, meter, kilogram, these are called unit. Meter is compared, meter is the unit for length, it is compared, length is being compared with meter. So, length and meter are of the same kind, same type. Length cannot be compared with kilogram, mass cannot be compared with meter. So, we are to take the standard of the same kind as the quantity. We will have length which is measured in meters or mass in kilograms. So, this standard is called unit. So, meter, kilogram, they are called unit, right. Now, whenever we are to measure a quantity, we need two parameters. One is the selection of unit, U, and second is the numerical value. These two parameters are very important for measurement of a quantity. Suppose I say length is 15 meter, then meter is the unit, 15 is the numerical value. Both are important, N and U. Either of them have no value in the measurement, no importance. Similarly, I say mass is 50 kilogram. In this case, 50 is numerical value and kilogram is the unit. In general, if we take quantity for Q, then Q is N into U. Q is equal to N into U, numerical value into unit, product of N and U. This is very important. So, we take both factors N and U, measurement of a quantity. Now, if I change 15 meter into centimeter, it will be 1500 centimeter. So, 15 changes to 1500, meter changes to centimeter. Bigger unit, smaller numerical value. Smaller unit, bigger numerical value. In general, we say N and U are reciprocal of each other. जिन्ना U ਵੱਡਾ होएगा उन्नी numerical value घट होएगी, जिन्ना U छोटा होएगा उन्नी numerical value ज़्यादा होएगी. So, the unit and numerical value are inversely proportional to each other. This is very important whenever we convert numerical value, whenever we convert bigger unit into smaller unit, the numerical value becomes more, that also. So, whenever we change centimeter to meter, then numerical value becomes small. Both are inversely proportional to each other. Now, we have some systems of units. First, I take the old three systems. One was CGS, another is FPS, another is MKS. These were for three quantities: length, mass and time. Only three fundamental quantities are covered in these systems: CGS, FPS and MKS. C means centimeter, G means gram, S means second, F means foot, P means pound, S means second, M means meter, K means kilogram, S means second. So, these three systems CGS, FPS and MKS are for three quantities: length, mass and time. Length in centimeter, mass in gram, time in second. In FPS system, it is length in foot, mass in pound and time in second. Pound means LB. This is symbol for pound. MKS, that is meter, kilogram and second. But these the three systems cover only the three basic quantities: length, mass and time. And you know, in science and engineering we have some other quantities which must be covered, and then a new system which was taken, That was our international system of units, which is written in short as SI. It has 7 basic units and 2 supplementary units. Like we had 2 type of quantities, basic and derived quantities, our units are also of 2 types. One is called fundamental or basic, and the second is called derived units. Fundamental unit ਕਿਹੜੇ ਹੁੰਦੇ or basic, which don't depend upon each other, which are not related to other units, they are called fundamental or basic units, and which are obtained from fundamental or basic unit, they are called derived units. Like unit of length, mass, time, they are called fundamental. Units of area, units of volume, units of density, they are called derived unit, which are obtained from fundamental units. So, in this system SI we have 7 basic units. Which are the 7 basic unit? We will make a table. Quantity, unit and symbol, sanket. First 3 are the same. Length, unit is meter, symbol is m. Mass, kilogram, small k, small g. Time, second, small s. Temperature, Kelvin, written with small k, but symbol is capital K. Electric current, ampere, A small, symbol capital. Luminous intensity, candela, small c, small d. And last, amount of substance, unit is mole, symbol is MOL. So, these are the 7, 1, 2, 3, 4, 5, 6, 7. 7 basic units and their symbols. These are the 7 basic units of SI, which is the International System of Units. This is very important because this is your foundation of whole science and engineering, where we will use such units for these 7 different quantities, and this system covers whole of our science and engineering. 2 supplementary units. In this system are radian, RAD for plane angle, and steradian that is for solid angle. Radian and steradian are 2 supplementary units of SI. So, these are the units of SI, International System of Units. Now, what are the characteristics of unit? A unit must have these characteristics. It should be well defined. It should be of suitable size. It should be easily approachable. It should be easily reproducible whenever we want to reproduce. It should be easily reproducible, invariant with place. It should not change from place to place. Invariant with time. The unit must not change with time. It should remain constant, same. So, these are the few characteristics. It should be accepted internationally, all over the world. कोई भी यूनिट असीं चूज करना है ਉਹਦੀਆਂ ਇਹ ਕਰੈਕਟਰਿਸਟਿਕਸ ਹੋਣੀਆਂ ਚਾਹੀਦੀਆਂ ਤੇ ਜਿਹੜੇ SI यूनिट ਹੈ ਜਿਹੜੇ ਆਪਾਂ ਹੁਣੇ ਲਿਖੇ ਆ ਉਹ ਸਾਰੀਆਂ ਇਹ ਕਰੈਕਟਰਿਸਟਿਕਸ ਜਿਹੜੀਆਂ ਹੈਗੀਆਂ ਉਹਨਾਂ ਨੂੰ ਓਬੇ ਕਰਦੇ ਆ। ਇਸ ਕਰਕੇ ਆਪਾਂ ਜਿਹੜਾ ਅੱਜ ਕੱਲ੍ਹ ਜਿਹੜਾ यूनिट हैगा वो असी सिस्टम जोड़ा यूज़ कर रहे हैं, दैट इज़ द SI इंटरनेशनल सिस्टम ऑफ यूनिट्स, राइट। नाउ वाई वी यूज़ SI, what are advantages of SI? First of all, it is a rational system of unit. One quantity, one unit, like कोई भी फोर्स है ਉਹਨੂੰ ਅਸੀਂ ਨਿਊਟਨ 'ਚ ਮੇਜ਼ਰ ਕਰਾਂਗੇ, ਚਾਹੇ ਗ੍ਰੈਵਿਟੇਸ਼ਨਲ ਹੈ, ਚਾਹੇ ਇਲੈਕਟ੍ਰੀਕਲ ਹੈ, ਚਾਹੇ ਮੈਗਨੈਟਿਕ ਹੈ, ਉਹਦੇ ਵਾਸਤੇ ਅਸੀਂ ਨਿਊਟਨ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ। ਨਿਊਟਨ ਇਜ਼ ਦਾ ਡਿਰਾਈਵਡ ਯੂਨਿਟ। ਕੋਈ ਵੀ એનર્ਜੀ ਹੈ, ਚਾਹੇ ਇਲੈਕਟ੍ਰੀਕਲ ਹੈ, ਚਾਹੇ ਕੈਮੀਕਲ ਹੈ, ਚਾਹੇ ਸੋਲਰ ਹੈ, ਉਹਨੂੰ ਅਸੀਂ ਜਾਊਲ ਦੇ ਵਿੱਚ ਮੇਜ਼ਰ ਕਰਦੇ ਹਾਂ। ਇੱਕ ਕੁਆਂਟਿਟੀ, ਇੱਕ ਯੂਨਿਟ। ਦਿਸ ਇਜ਼ ਦਾ ਐਡਵਾਂਟੇਜ ਆਫ SI। ਜਿਹੜੇ ਪਹਿਲਾਂ ਸਿਸਟਮ ਹੁੰਦੇ ਸੀਗੇ ਉਹਦੇ 'ਚ ਇੱਕ ਇੱਕ ਕੁਆਂਟਿਟੀ ਦੇ ਕਈ ਯੂਨਿਟ ਹੁੰਦੇ ਸੀਗੇ, ਇਸ ਕਰਕੇ ਉਹਦੀਆਂ ਜਿਹੜੀਆਂ ਉਹ ਡਿਸਐਡਵਾਂਟੇਜ ਸੀਗੀਆਂ। ਤਾਂ SI ਦੇ ਵਿੱਚ ਇੱਕ ਐਡਵਾਂਟੇਜ ਆ ਗਿਆ ਕਿ ਇਹ ਰੈਸ਼ਨਲ ਸਿਸਟਮ ਹੈ, ਇਹਦੇ 'ਚ ਇੱਕ ਕੁਆਂਟਿਟੀ ਦਾ ਇੱਕੋ ਹੀ ਯੂਨਿਟ ਹੁੰਦਾ ਹੈ। ਦੂਜਾ ਐਡਵਾਂਟੇਜ ਹੈ, ਇਹ ਕੋਹੇਰੈਂਟ ਸਿਸਟਮ ਹੈ। ਕੋਹੇਰੈਂਟ ਸਿਸਟਮ ਦਾ ਮਤਲਬ ਅਸੀਂ ਜਿਹੜੇ ਡਿਰਾਈਵਡ ਯੂਨਿਟ ਹੈ, ਡਿਰਾਈਵਡ ਯੂਨਿਟ, ਉਹਨਾਂ ਨੂੰ ਅਸੀਂ ਫਰਾਮ ਬੇਸਿਕ ਯੂਨਿਟ ਈਜ਼ੀਲੀ ਡਿਰਾਈਵ ਕਰ ਸਕਦੇ ਹਾਂ, ਈਜ਼ੀਲੀ ਓਬਟੇਨ ਕਰ ਸਕਦੇ ਹਾਂ। ਜਿਵੇਂ ਏਰੀਆ ਹੈ, ਲੈਂਥ ਐਂਡ ਟੂ ਬ੍ਰੈਡਥ, H मीटर भरो, H मीटर भरो, you will get the unit of area, मीटर स्क्वेयर। सो बेसिक नू मल्टीप्लाई करके, दो बेसिक यूनिट नू मल्टीप्लाई करके एरिए के यूनिट आ गए, सिंपली मल्टीप्लिकेशन की। सो एक कोहेरेंट सिस्टम हो गया जिहदे च नो न्यूमेरिकल फैक्टर, नो न्यूमेरिकल फैक्टर, कोई न्यूमेरिकल वैल्यू नहीं असी लगानी पई सानू, असी सिंपली जिहड़ा हैगा बेसिक यूनिट नू मल्टीप्लाई किया। इस तरह असी दो नू डिवाइड करके असी जिहड़े यूनिट ऑबटेन कर लांगे। जिवें डेंसिटी है, डेंसिटी हुंदी है मास ओवर वॉल्यूम। सो मास दे यूनिट भरो, वॉल्यूम दे भर दो, यू विल गेट द यूनिट ऑफ डेंसिटी। Such units are called derived units, meter square, kilogram per meter cube, which are obtained from fundamental or basic unit. They are called derived units. So, we must have the knowledge of fundamental or basic and derived unit. कोई भी यूनिट ਆਪਾਂ ਨੂੰ ਦਿੱਤਾ ਆਪਾਂ ਨੂੰ ਕਲੀਅਰ ਹੋਣਾ ਚਾਹੀਦਾ ਕਿ ਇਹ ਫੰਡਾਮੈਂਟਲ ਹੈ ਕਿ ਇਹ ਡਿਰਾਈਵਡ ਹੈ। ਜੇ ਤਾਂ ਮੀਟਰ ਹੈ, ਮਾਸ ਕਿਲੋਗ੍ਰਾਮ ਹੈ, ਤਾਂ ਇਹਨਾਂ ਨੂੰ ਆਪਾਂ ਜਿਹੜਾ ਹੈਗਾ ਉਹਨਾਂ ਨੂੰ ਬੇਸਿਕ ਲੈਂਦੇ ਆ। ਜੇ ਉਹਨਾਂ ਨੂੰ ਮਲਟੀਪਲਾਈ ਕਰਕੇ ਜਾਂ ਡਿਵਾਈਡ ਕਰਕੇ ਅੱਗੇ ਯੂਨਿਟ ਬਣਾਇਆ ਹੈਗਾ ਤਾਂ ਉਹ ਜਿਹੜਾ ਹੈਗਾ ਤੁਹਾਡਾ ਡਿਰਾਈਵਡ ਯੂਨਿਟ ਬਣ ਜਾਏਗਾ। ਸੋ ਦਿਸ ਇਜ਼ ਵੈਰੀ ਇੰਪੋਰਟੈਂਟ। ਤੀਜਾ ਜਿਹੜਾ ਐਡਵਾਂਟੇਜ ਹੈ ਉਹ ਹੈ ਇਹ ਮੀਟ੍ਰਿਕ ਸਿਸਟਮ ਹੈ। ਮੀਟ੍ਰਿਕ ਸਿਸਟਮ ਦਾ ਮਤਲਬ ਇਹਦੇ 'ਚ ਅਸੀਂ ਪਾਵਰ ਆਫ 10 ਯੂਜ਼ ਕਰਦੇ ਹਾਂ। ਪਾਵਰ ਆਫ 10 ਦਾ ਮਤਲਬ ਕੋਈ ਵੀ ਅਸੀਂ ਐਕਸਪ੍ਰੈਸ਼ਨ ਅਸੀਂ ਲਿਖਣਾ ਹੈਗਾ ਉਹਦੇ 'ਚ 10 ਦੀ ਪਾਵਰ ਲਿਖ ਕੇ ਉਹ ਆਪਾਂ ਇਹਦੇ 'ਚ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ। ਸੋ ਇਟ ਇਜ਼ ਮੀਟ੍ਰਿਕ ਸਿਸਟਮ। ਅਨਦਰ ਐਡਵਾਂਟੇਜ ਇਜ਼ ਕਲੋਜ਼ਲੀ ਰਿਲੇਟਡ ਟੂ CGS। ਪਹਿਲਾ ਸਿਸਟਮ ਜਿਹੜਾ ਆਪਾਂ ਡਿਸਕਸ ਕੀਤਾ ਸੀ CGS, ਕਲੋਜ਼ਲੀ ਰਿਲੇਟਡ ਟੂ CGS, ਕਿ SI ਤੋਂ CGS ਜਾਂ CGS ਤੋਂ SI ਕਨਵਰਟ ਕਰਨਾ ਹੋਵੇ ਇਟ ਇਜ਼ ਵੈਰੀ ਈਜ਼ੀ। ਜਿਵੇਂ ਆਪਾਂ ਕਹੀਏ 1 ਮੀਟਰ ਦੇ ਕਿੰਨੇ ਸੈਂਟੀਮੀਟਰ ਹੁੰਦੇ ਆ 100 ਸੈਂਟੀਮੀਟਰ, तो मीटर ਦੇ ਸੈਂਟੀਮੀਟਰ ਬਣਾਣੇ ਆ। ਸੋ दैट इज़ वेरी ईजी, और रादर इट कैन बी रिटन एज 10 दी पावर 2 सेंटीमीटर। पावर ऑफ 10 ही यूज्ड। जे 100 लिखना है तो वो 100 लिखने की बजाय आप 10 की पावर 2 लिख दें। 1000 लिखना हो तो 10 की पावर 3। इस तरह जिन्हें जीरो लगे हो 1 की पावर उन्होंने 10 की पावर बना के वो हो जाता है। 2 जीरो लगे तो 10 की पावर 2 एंड सो ऑन। सो एडवांटेज ऑफ SI। इस तो बिना कुछ होर यूनिट असी यूज़ करते हैं। कुछ लार्ज यूनिट असी यूज़ करते हैं। वन इज़ कॉल्ड एस्ट्रोनॉमिकल यूनिट, वन इज़ लाइट ईयर, another is parsec। Astronomical unit is the distance between sun and earth, 1.5 10 the power 11 meter। Light year is 9.46 10 the power 15 meter। Parsec is about 3 into 10 the power 16 meter। इस तरह कुछ छोटे यूनिट ही यूज़ करते हैं, स्मॉलर, जिन्हां च एंगस्ट्रॉम आंदा हैगा 10 दी पावर -10 मीटर। नैनोमीटर आंदा 10 दी पावर -9 मीटर। फर्मी आंदा हैगा 10 दी पावर -15 मीटर। Such units are very important. Somewhere that they will be used whenever we discuss in numerical problems. There will be some angstrom, nanometer, Fermi, which is called femtometer. So they are very important in this chapter, that is the units. The second topic is which we will discuss today, that is the dimensions. Dimensions are powers to which the basic units must be raised to obtain the derived units of that quantity. They are called dimensions. The powers to which the basic unit must be raised to obtain the derived units of that quantity, they are called dimensions. If I write L for length, M for mass, T for time, theta or K for temperature, current is written in term of A, then any quantity